We've all been there, right? Trying to break down something super complicated, like explain it to someone who's 5 years old.
Right, right.
But what about going the other way? Like, what if we tried to explain things not simpler, but to like the smartest people out there? How do those super brains really learn?
Well, that's a really interesting thought, isn't it? Because when you're talking to a real expert, you're not just, filling in the basics.
Yeah.
You're trying to connect with all the knowledge they already have.
Yeah,
It's almost like adding to a giant puzzle.
exactly. So that's exactly what we are going to do in this deep dive. We're going to figure out how people understand things, how we learn, and how even the most brilliant people wrap their heads around brand new ideas. And to do that, we're diving deep into the stuff you sent us, especially that book by Thomas Kuhn, The Structure of Scientific Revolution.
Oh, yeah, that's a classic, a perfect choice, actually.
Yeah.
Kuhn himself really struggled with how scientific understanding changes, even for the top scientists.
Right.
So we're going to pull out the really key ideas from it to see how even a genius learns.
So right away, we see something really important. Even the people who come up with totally new ideas in science, they have to change their own understanding sometimes, too. Just like Kuhn himself. His switch from physics to the history of science, that wasn't a simple change, was it?
No, it wasn't. You know what's really interesting? His training in physics and his philosophy, they just didn't match what he saw happening in the actual history of science.
Oh.
He called it a failure of verisimilitude. His old ways of thinking just didn't fit with the real world of science. And this wasn't just a small problem for him. It
Right.
was like a complete mismatch.
Wow. So instead of ignoring this failure, he made it the focus of his whole career change. It's amazing, isn't it? Even someone as smart as Kuhn had to face these huge gaps between what he thought he knew and what he was seeing. It made him completely change his thinking. I think it shows us how important it is to be flexible, even when you're super smart.
I completely agree.
Mhm.
And if we think about this on a bigger scale, it tells us something important about how we all learn, even geniuses. No one starts from scratch.
Mm.
Everything we've learned before, all our experiences, they matter.
Yeah.
Remember, Kuhn himself said that his background and even random things that happened while he was researching shaped what he ended up believing. Even thought about how people's beliefs about the stars might have affected early chemistry or how we understand electricity.
Fascinating. So even for the brightest people out there, learning isn't just about soaking up facts like a sponge. It's more like they have this super complex web of ideas, and anything new has to fit into that web somehow.
Yes, exactly. And Kuhn talks about this powerful idea of paradigms. You can think of them as the foundation of knowledge, the accepted beliefs and frameworks within a scientific community. He says that real, effective research only starts when a community thinks it has solid answers to the big questions. Like, what is the universe?
Well,
How do things interact? What questions should we even be asking? And what are the right ways to find answers?
right. And these paradigms, this basic knowledge, it's not like you just pick it up by being around it, right? Kuhn says that it gets really ingrained through a lot of training and education. He even says it's rigid.
Absolutely.
Yeah.
That's the thing. This intense training, even for people who will eventually change the game, it plants these beliefs deep inside them. It's the foundation for what Kuhn calls normal science. This shared understanding is why scientists can be so effective in their everyday work.
So even someone who's going to be the next Einstein, they go through the same process of absorbing the existing paradigm. It makes you think, even with all that brain power, do they still rely on these basic ideas to guide their early research?
That's a great question, and Kuhn's answer is a definite yes. These paradigms are like the boxes that normal science works within. They decide what problems are important and what methods are okay to use.
And that leads to what Kuhn calls the puzzle-solving nature of normal science. It's not always about discovering huge new truths. What's interesting here is that even brilliant work within a paradigm is often about refining and mastering the tools we already have.
You got it. He says that normal science is all about trying to force nature to fit into the boxes that our education gave us. Most scientists, even the geniuses, spend their time solving puzzles defined by the existing paradigm. Their goal isn't to break the system, but to work within it, to solve problems using the rules everyone agrees on.
Right, and if they can't solve the puzzle, it's seen as their fault, like they weren't clever enough. Not that the paradigm itself is wrong.
Yeah, that's key. The challenge is how to get the expected results in a new or better way. This requires serious problem-solving skills, whether it's with tools, concepts, or math. It's about mastering what we have within the accepted framework.
So within these paradigms, scientists are like master puzzle solvers. But what happens when those puzzles just won't be solved, when the tools just don't work? That's where those anomalies pop up, right?
That's exactly right. Kuhn says that while paradigms are super helpful for research, they can also stop scientists from seeing new important things. But when anomalies show up, problems that can't be solved using the normal rules, that's when things start to break down.
Yeah. He calls this a crisis of the paradigm. And he has some great examples, like the problems with Ptolemy's model of the universe before Copernicus came along, the issues with Aristotle's ideas about motion before Galileo, and the problems with Newton's theory of light before the wave theory was accepted. It's like cracks start to show in the foundation of what we think we know.
And here's the cool thing. When a really smart person runs into a big anomaly, it can be the spark that starts a revolution in thinking. When the old way breaks down, it opens up space for new ideas.
Right.
These anomalies create tension that just can't be solved with the current way of thinking. It forces everyone to rethink the basics.
And when that tension gets too strong, that's when we see a paradigm shift, a scientific revolution. But Kuhn makes it clear that this isn't just knowledge slowly building up over time.
Nope, he says it's not about adding to what we already have. It's like completely rebuilding from the ground up. It's like we're not just adding pieces to the puzzle, we're changing the whole picture on the box.
Right, right.
It means changing the most basic theories, the methods we use, even how we apply the science.
He uses that great analogy of picking up the other end of the stick, or that picture that suddenly flips from a rabbit to a duck. It's like a sudden change in how we see things.
Yes, the Gestalt switch, that's what it's called.
Right.
It's a perfect way to describe how quickly our perspective can change. Kuhn says scientists don't just start seeing something as something else, they actually see it differently. It's like with Lavoisier and oxygen. Priestley found the gas too, but Lavoisier saw it as part of a new way of understanding burning. He already knew the problems with the old theory, so he was ready to see things differently.
And being stuck in the old way of thinking can really block us from seeing new things, right? Kuhn points out that Priestley was so attached to his experiments and his old theories that he missed the real importance of oxygen.
Exactly. He was so focused on what he already knew that he couldn't see how important his own discovery was. This shows how powerful those ingrained paradigms can be, even for brilliant minds.
So when a new paradigm takes over, Kuhn talks about this idea of incommensurability. It's not just that the old and new ideas disagree.
It's way deeper than that.
Hmm.
Kuhn says that different paradigms are like describing completely different universes.
Whoa.
They might disagree on basic things like whether subatomic particles exist or not, or the nature of light, or even the laws of physics that we think govern everything.
So it's not just different answers to the same questions. It's like they're asking completely different questions or even defining the questions in totally different ways.
You got it. They also use different methods, they're interested in different problems, and they even have different standards for what counts as a good solution. Some problems that were super important before might become irrelevant in the new paradigm, while totally new areas of research become crucial. It's like they're speaking different scientific languages, even when they're using the same words.
Yeah, he gives the example of how people saw substances and the role of phlogiston before and after the chemical revolution. It's like they had completely different ideas about what matter is and how chemical reactions work.
Totally. What was a perfectly good explanation in the old paradigm just doesn't make sense in the new one.
And this paradigm thing, it doesn't just change the theories and how scientists talk about things. It even changes what they actually see, doesn't it? That seems kind of strange.
Yeah, it's a really important point, and it can be hard to wrap your head around. Kuhn says that paradigms directly affect what scientists observe. He uses that famous example of Aristotle and Galileo watching a swinging stone. Aristotle, with his ideas about natural motion and gravity, saw an object trying to get back to its natural resting place. But Galileo, influenced by the new idea of impetus, saw a pendulum, something that swings back and forth in a predictable way.
So it's not just that they understood the same thing differently, they actually perceived the event itself differently.
Exactly. What Aristotle saw as one thing, Galileo literally saw as something else.
Wow.
Kuhn says that Galileo's insight was possible because of an earlier, subtle shift in thinking, that impetus theory. That change in how they thought about motion allowed him to see the swinging stone as a pendulum, something that could be studied scientifically. Before that idea existed, there were only swinging stones, not pendulums, as a specific concept in science. It's like the paradigm changed not just how they explained things, but how they saw the world.
That's mind-blowing. It means that even a genius's observations aren't completely objective. They're shaped by the way they understand the world, often without even realizing it.
It's so true. And when we talk about explaining something to a genius, we're not just giving them facts. We're asking them to see those facts through a different lens, one that might require them to change how they fundamentally perceive things. And Kuhn talks about the importance of tacit knowledge and exemplars in this process. Tacit knowledge is the kind of understanding you get from actually doing something, the know-how that's hard to explain with rules.
It's like learning to ride a bike. You don't get it from a book, you learn by doing it, right?
Yeah, exactly. And scientists get a lot of this tacit knowledge by working with exemplars, which are the successful solutions to problems from the past. It's not just about applying rules, it's about seeing new situations as similar to those old problems and understanding the patterns, almost like an expert intuition. This way of seeing things is crucial if you want to be part of a scientific community.
So even for a genius entering a new field or trying to understand a revolutionary new idea, they have to learn how to see the problems and solutions in the way that everyone else in that field does.
Absolutely. And this leads us to the problem of communication when paradigms shift. People from different paradigms might use the same words, but they mean totally different things by them because their basic understandings are different.
It's like they think they're talking about the same thing, but they're really not because their underlying ideas are totally different.
Exactly. Kuhn says you can't really prove that one paradigm is better than another using logic or facts because they start from different places and have different ideas about what counts as evidence. So persuading people becomes more important than just proving things logically. It often involves trying to understand how the other side sees the world.
He talks about going native in a new paradigm. It's not just deciding to agree with a new theory, it's a much deeper change in how you think and work.
It's like you absorb the new paradigm so completely that you start to see the world through its lens without even realizing it.
Bringing it all back to our original question, even for a genius, understanding something completely new isn't about just absorbing new information. It's a way more active and transformative process. They have to engage with the existing paradigms, grapple with anomalies that challenge those paradigms, and maybe even change how they see the world.
And it's not just a cold, logical process. Their past experiences, the scientific community they belong to, and even their basic perceptions all play a part. It's a much more complete and transformative experience than just adding new facts to what they already know.
So when we think about explaining to a genius, it's not about making things simpler. It's about recognizing that even the smartest people have to go through this difficult and sometimes revolutionary process of learning and changing their understanding. It's about how they use their incredible minds to navigate the complexities of knowledge and how their thinking can be totally transformed by new ideas.
Think about a time when you learned something totally new in your own field. How did your existing knowledge affect how you understood it? Did you experience anything like a paradigm shift in your own thinking? What were the things that didn't fit with what you already knew, the things that made you change your mind? Thinking about that, no matter what your area of expertise is, can give you a glimpse into how even the most brilliant people in the world learn to see the world in new ways.
That's so true. Understanding these deep learning processes and paradigm shifts is important for anyone who wants to learn and grow, no matter how smart they are.
Right. It helps us appreciate the challenges and the power of truly understanding something new.
And on that note, we've reached the end of our deep dive.
Thanks for joining.
Until next time.